Hello my friends, welcome to Install Electronic. This is Uncle Misha. Today on the bench we have a device. Honestly, I do not 100% understand what this device is, but I have a suspicions. So let's together figure out what it is, how it works, and if it works at all. Alright, I think this device is a device which measures the distance, because it says, well, measurement computer means anything, right? It has opening, alright, over here of some kind, and there is lots of dust in this thing, and there is a little grill down there. So there is a whole bunch of things, buttons, I mean, there is a screen, bunch of buttons, some clear, some mode, recall L, WH, so I assume the length, width and height, area, volume. So this device, I assume, measures distances, and it says aim squarely at flat surface, press and release sidebar on buttons, measure from base, and a whole bunch of things. So this device is clearly measures the distances. It comes with a bunch of batteries, which I presume are completely dead, because this device does not power on. So we have to obviously remove all this. I don't even remember where I got it from. Honestly, I don't remember. It's kind of, I've never seen the Panasonic batteries that instead of kind of puffed up, actually concave. Yeah, those are actually has like, you see that? Unless this is by design, but all of them it's like have a dimple. And this one too. That's crazy. I never seen this before, unless I'm just don't have much of experiences. And let me measure those, but I assume they are gone. So I need 3. Still 9 volt. Oh well, this is not 2. Okay, well they are dead. So yeah, we need 3. It's like 9 volt. Yeah, I don't know, would be better to have a 9 volt single cell, a 9 volt battery, or 3 of this kind. Kind of debatable. So I have to find 3 batteries, but before I go there, I would like to kind of open it up and see what's going on. And for this I'm going to be using my newly acquired Viha freaking long screwdriver, which is obviously over too much for this particular use, but it's very nice to actually give them a try. Start using those nice looking screwdrivers. 3 screws are holding this thing together. Self toppers. Alright, it's not too bad. Relatively easy to open. Just, oops, what is this? What's the button? Oh, wow, just like, oh, it has also buzzer. Is it? It is buzzer. It's a lot more going on than I expected to be. So we have our, I assume, inducer of some sort. Yeah. So around 2, 3, 4 ACs. IC is curious what's on the other side. There's a bunch of jumpers here for some reason. Probably some. Kind of unscrew that. There is no corrosion going on here. So let me. Oh, there's also has to be like a display controller probably on the back side. Oops, it's too long of a screwdriver for this operation. But feels so nice. I'm not sure when it was made. I see no date codes at the moment. Maybe on ICs. Lots of screws, probably because they need to hold the screen and buttons. Which is the following footsteps of one of my favorite YouTuber, which says, don't turn it on, take it apart. So I love to do so. Okay. Here we are. So we have like a module right here. This is actually quite not. What is? Oh, it's inductor. Look at this cool inductor, or it's capacitor. What the heck is this? This is cool. Transformer. Okay, this is transformer. It's a capacitor. It's not much going on this side. Elma capacitor. Look at that. And Fijicon. This is Fijicon. This is Elna. Like, if you could afford Elna, why would you not put two Elnas proper? Oh wow, it has also. Why do you need thermistor here? That's weird. Anyways, so not much going on the side of over here. So there is a resonator right there, and there is a blob, which probably drives the display controller. Okay, on this side, let me take some photos first and zoom a little bit closer. Alrighty. Okay, so I did some figuring out and figuring out some of the components. This particular guy took me some time to scrape off some kind of gunk. I don't know, they want to protect it from the prying eye or something, I don't know. But anyways, so first of all, let's start from the piezo inducer. So this gentleman right here is a piezo inducer ultrasonic transducer. It's 40 kilohertz, whatever capacitance is, but it's 115 dB at 40 kilohertz. That's pretty loud actually at 40 kilohertz. So I like to play with that. So then we have this gentleman right here and the capacitor. So this is sort of that giveaway that this is voltage regulator, and it is. It's 100 volt, 100 milliamp adjustable voltage regulator. I'm not sure what kind of voltage it's set to. I can measure, no problem. But yeah, next one is precision dual op amp. So TI272i is this gentleman right here. Okay. This guy is kind of weird. I'm not 100% sure that this is what I think it is, but the only thing I could figure out by these numbers, I could figure out nothing. But this number is brought me to have a 4T11B 2 input non-logic gate. Is it judging by what's around it, especially this potentiometer, I'm not 100% sure. I thought this is like a microcontroller, but could not find information. It says one row is 0336WC, second row is 4011B. That's all I can have. It's not nothing. This could be date code, or this could be date code. Who knows? So yeah, and unless this blob right here does the microcontroller duties and also does the output and processing buttons, maybe. So this could be like a gate for whatever reason. So next one, this guy is, which took me some time to figure out and to scrape this crap out of it. So it is LM393M dual differential comparator, which is kind of makes sense to have here. And the last one is this Holtec low voltage regulator right here is set to 1.5 volt for sure. So this is what we have. Now the only thing is to get fresh batteries. I have prepared some IKEA Plat Boys that I have in stock, and just give it a try. Just like gonna assemble it quickly off camera, and we're gonna play with this gentleman quickly. So here we are. It is properly assembled, and let's give it a try. So in order to activate, I need to press the button. It produces those like high pitch clicking noises, and it measures the distance of 2.3 feet to the end of my table. Let's just move a little bit further down and press it again. 1.6. Yeah, that's more like it, because 2. Whatever was before is wrong. Let's measure it opposite direction, behind my back. Yeah, looks like it's... Let's try again. It just wall behind me, 99.9. It's about correct. Not sure if I can... Oh yeah. Meters, feet, inches. Okay, let's see. Looks like the gentleman having problem with, yeah. Error. Okay, so looks like we have a problem, and this gentleman can only measure something which is above 1 feet 8 inches. Yeah, it's like it cannot measure inches, it just feet plus and meters, right? So if you go mode 0.53, yeah, so we have a little bit of a problem. Clear some, well, okay, cool, that's interesting. And can do area, volume, this is all nice. So you can essentially measure the length and width and height, and actually calculate area and volume, which is nice. Let's activate again. Clear some. Anyways, so that device is fairly simplistic. I'm not sure what about the precision, so I have to kind of pull out my measuring tape and see how precise is this guy. But for eyeballing, I think that's gonna be pretty much good. Another problem, I tried to measure distance not 90% to the surface or to the wall, for example, but like on an angle, and the beam was actually bouncing off. So yeah, you have to like do it 90 degrees. So if you have a complicated surface, that's could be your another problem. So in this case, I think the laser rangefinder would be much more appropriate than this device, but nevertheless, this is kind of cool device, which I don't know where I got it from. So good to have around for some kind of very simplistic measurements of width, height, and length, especially in the house, like between walls and furniture, which doesn't have complex shapes and stuff like that. Alright, so we did figure out what's inside, we did figure out that it works and put it together. So let's talk about how it works, alright? Okay, so let's look about some theory here. So what do we have? We know that there is ultrasonic sensor somewhere down here. And let's talk how this ultrasonic sensor works. So let's draw it with blue color. So this is our ultrasonic sensor, or actually transducer. It's not a sensor, okay? This is transducer. It has two outputs, okay? This is how this thing being driven. So it outputs 40 kilohertz. So we know that it outputs 40 kilohertz, and they are the waves being transmitted with the speed of sound. And here there is the object. So the waves being transmitted. They obviously, because it's like a kind of funneled, they're gonna probably go a little bit kind of that, kind of like a wider angle, and then they're gonna hit the object, right? Obviously it's gonna be quite fast, and then they're gonna bounce back, and the waves which are bouncing back will be detected by this transducer. But how does it work? It is transducer, it's actual outputs. So the trick here that you have to switch transducer into the transmit mode, send the pulse. So for example, you're gonna send the pulse in, and then after some certain time you have to stop pulsing and sense. So after that you're gonna receive some kind of pulse. So what you're gonna do, you're gonna measure the timing between this pulse and what you receive, and essentially a measuring time of flight delta t, or time of flight. So based on that, knowing the speed of sound in air, well, probably at normal temperature, you're gonna know what the distance is. The only trick here that you have to switch between transmitting and sensing, all right? Because there are some other ultrasonic distance measuring devices where they have transducer and another one is a sensor. So essentially these two devices work separately. They simultaneously can transmit and sense. the wave essentially what they are outputting. So obviously this is much easier to work with. This is a bit harder to work with because you have to switch this device into the transmit and receive essentially mode, and you have to also do it correctly, because if you do it too fast, this wave may not even bounce back. If you do it too slow, you may get some kind of echo. So obviously there should be a minimal and maximum times you transmit and receive, and the essentially frequency of pulses. So you have to have enough time between pulse, wait, receive, pulse again, something to this extent. All right, so I had experience only working with these guys, but don't have any experience to working with these guys. But the theory is like that. All right, so I think the theory part is pretty much done, and I'm gonna be wrap up at this one. So I think this is useful device, but after using it for a little bit, I noticed it's not as precise. So I would like to have it a little bit better precision. So guys, so here we are. We figured out how a Mastercraft measurement computer, which is based on ultrasonic transducer, works. If you find this video interesting, please like, subscribe if you like my videos, stay tuned for more, stay safe, and ciao.